Namaskar and welcome to StudyIQ. I am your friend Rahul Saigaonker. Let's continue our discussion of NCERT Science series. We are discussing Science textbook for class 9 and today's agenda for discussion is chapter 11, that is work, power and energy. I hope you remember chapter 10. In our previous interaction, we discussed gravitation. We discussed the universal law of gravitation. Every object attracts another object through some sort of gravitational force, which depends on the masses of the two bodies and inversely proportional to the square of the distance between them. And that's why we established that celestial bodies, they apply or they create large amount of gravitational forces. Right? We also understood many other concepts connected to it. We ended our discussion with the understanding of buoyant force. Today we'll move on and discuss chapter 11, which is rather simple. We'll discuss some of the basics of work, energy and power. All right, we'll understand the definitions, we'll understand different forms, we'll also talk about law of conservation of energy. So without any further delay, let's begin our discussion. But before that, please note that StudyIQ has launched the Prelims to Interview initiative. It has already begun from 19th of June. Only orientation class is done, but you can still enroll for this program because the admissions for this are closing on 30th June. There are limited number of seats. They're filling very fast. You have a short window to enroll yourself. If you have done it, I'll see you in the class. If you have not done it, you'll be missing out on a huge opportunity to join the most comprehensive batch for UPSC civil services preparation. So spread the word. Please let others also know that Prelims to Interview initiative is running. If you know any relative, any siblings, your cousins, etc., let them know about this program, because StudyIQ believes in quality education at affordable prices. This entire program, where we will be hand-holding you in prelims, mains, interview, it is priced at a very affordable range. If you want to get highest discounts, then do use my code Rahul Live. Right, let's begin our discussion. As I told you, today's interaction is about work, energy and power. Now, how do we define work? In our day-to-day life, how do we define work? Right now I am working, right? For me, working is this class, right? Taking this class. So this is this work? In our day-to-day work, say in our day-to-day life, for instance, if I'm reading, do I consider reading as work? Do I consider eating as work? Do I consider playing as work? Generally, in our normal parlance, in our day-to-day life, whatever requires some sort of mental or physical labor, that is categorized as work. And if you do something for passing your time, that is not considered as work, or at least useful work. That is the basic definition or basic idea of work. But we are going to discuss in this particular lecture the scientific notion of work. What is the meaning of work in scientific terms? Let's try to understand that, right? Now, work and its scientific conception, it is based on two concepts. It is based on the concept of force, and we have already established. So let me just give you a small recap of our Newton's laws. I told you second Newton's law, it leads to the idea of force, which is equal to mass into the acceleration. We have also discussed some other aspects connected to physics, where we have seen the idea of displacement. That means an object or a thing moving from point A to point B, displacement. All right. Now, work is connected to these two aspects or these two topics. For example, there is a pen. If I put a pen on my hand like this, and if I push a pen from here to here, is the work done? Yes. In scientific terms, it is done. Why? Because the scientific notion of work is based on the concept of force. You apply certain force on some object and there is some sort of displacement. That is the scientific idea of work. So work is basically equal to the applied force into the displacement that takes place. If there is no displacement, according to the scientific definition, there is no work done. Or let's say, for example, if there is a wall, I'm simply pushing the wall, the work done is zero. I am applying the force, but the displacement is zero. There is no work done. Useless work. That's the definition from our common day-to-day activities or day-to-day life, right? So what is the idea of work? Work is the amount of energy that is transferred. One notion is this also. We'll talk about this when we discuss energy. But scientifically, from a formula perspective, work is basically force that you apply into the displacement that occurs. Again, if we delve a little deeper, then we'll understand that work, which is equal to transfer of energy, it can be said to be the product of force and displacement. And if we are applying force at one particular angle, say for example, this is a block, I can pull the block in this direction, the angle of force and the displacement would be 0. But if you're applying force in this direction and the displacement is in this direction, then the angle between these two is used to calculate work. So work done is equal to force into displacement into cosine of the angle between force and the displacement. So on the basis of this scientific explanation or scientific idea of work, we can understand that work can be actually negative, work can be positive, or work can even be 0. For instance, this little girl is pulling this car by a thread. She's pulling this car towards her. That means she's applying some force. We established that force is a push or a pull. So she's pulling. So she's applying some force in this particular direction. And you can see that the car is also moving from point A. Say, imagine it moves to point B somewhere here. Then this is the displacement. That means there is positive work being done. Means the force and the displacement, they are in the same direction. This is called as positive work. But work can also be negative. For instance, if the car is already traveling in this particular direction and I go in front of it, imagine I am the Hulk. I go stand in front of the car and I stop it. That means the car is moving in this direction. I have applied the force from this direction. The car has come to halt. That means there is some sort of change in motion. That means the displacement is negative, meaning the work done can be negative also. So work done can be negative, work done can be positive, work done can also be 0. As I told you, work done, it depends on force into displacement into cosine of the angle between force and displacement. So if force and the displacement, they take place in same direction, what is the angle between them? The angle is 0 degrees. If the angle is 0 degrees, cos 0 is 1. So it is basically to force into displacement, positive work done. Similarly, if force is applied in opposite direction and displacement takes in the other direction, then the work done is negative. Why? Because the angle between force and displacement now is 180 degree and cosine of 180 degree would be -1, which is negative work done. But imagine a scenario where you apply force in one direction, displacement is perpendicular to it, then the work done is actually 0. Why? Because the angle between them is 90, cosine of 90 is 0. So work done can be positive, negative, or 0. That's the scientific idea of work. Clear? Right. Let's move on to the next concept. That's energy. Now, energy is very important for all of us. Life is impossible without the energy, and ultimate source of energy, we say, is sun. Sun provides us light energy, heat energy, because of which life is surviving, right? Life is running, life is sustainable. Sometimes we say, I'm innervated, right? I've lost all my energy. I want to have Glucon-D, I want to have Gatorade, so that I energize myself. So energy is also used in our daily parlance, right? And energy is again connected to the concept of work itself. Energy is the ability to do that work. So work and energy, I would say, they are analogous, or many times we can define them synonymously also. As I told you, as I showed this, force is equal to mass into acceleration, force into displacement is equal to your work done. So energy is basically required to employ this force, meaning if I want energy, if I have energy, through this energy, what I can do, I can employ force. And when I employ force, I'll be able to displace things. And if I displace things, then the work is done. That is the meaning of energy. Energy is the ability to do work. You need energy to force an object to move. You need energy to stop an object which is moving. You need energy to displace something from one spot to another spot. So energy can be in different forms. Energy can be in various forms. For example, see, right now, I have energy because of which I am able to hold this pen. I am going to push this pen from here to here. Blowing wind can have energy. light, photons have energy. So energy is almost everywhere. Energy is something that brings motion or change possible. All right. Now, what kind of energy do we find? There are different forms of energy. Right? We find there's light energy, there is heat energy, there are so many different kinds of energy, electrical energy, chemical energy, etc. But in general, we categorize energy into two broad classifications. That is potential energy and kinetic energy. And under that, you can see the classification: potential energy. Chemical energy is the example of potential energy. Stored mechanical energy, for example, spring or a bow, that is example of stored mechanical energy. The gravitational potential energy, nuclear energy, all these are example of potential energies. There's one more classification: kinetic energy. Kinetic means something which is in motion, something which is moving, which is in motion. So electrical energy is example of kinetic energy because electrons are moving. Radiant energy, photons are moving. Thermal energy, heat is moving from one spot to another spot. That means energy is being transferred through the atoms, molecules. Motion energy, sound energy, again vibration is moving. So broadly, we categorize energy into potential and kinetic energy. So let's talk about these forms. Kinetic energy, by name itself, kinetic, meaning it is by virtue of its motion. If something is in motion, then it will have kinetic energy. All right. So kinetic energy is energy of an object by virtue of its motion. A meteor or an asteroid moving, it has energy. If it comes and hits Earth, a crater would be created. I am throwing a ball. That means this ball has energy. This ball is in motion. It has energy. If it hits me, it's going to give me some injury. If I am walking, I have energy, or I have kinetic energy. I have some sort of momentum. If I'm falling, or if I throw some object from upwards, if it is in motion, then it has kinetic energy, right? So kinetic energy is something which is because of the motion of an object. It is because the virtue of that motion. A moving object can do work, and faster the object moves, faster work can be done. So kinetic energy can be used to do work, because energy, as I told you, what is energy? Energy is the ability to do that work. And how do we categorize? For example, kinetic energy. There is a moving bullet, there is a moving ball, blowing wind, rotating wheel. Everything has kinetic energy in it. How do we define kinetic energy? What does it depend on? Now, we have already established the simple equations of motion. One of the equations of motion was this: v square is equal to u square plus 2as, or v square minus u square is equal to 2as. Now if you simply reorganize this particular equation, you'll get s is equal to v square minus u square by 2a. Now from this particular section, we do understand that work done is equal to what? Work done is equal to force, mass into acceleration, into the displacement. Now displacement is this. There is no need to focus on derivation, but I want you to arrive at this particular thing, because energy or work, I told you what is energy. Energy is the ability to do work. So energy and work can be understood synonymously here. So kinetic energy would be this particular entity. And many a times, if a body is at rest, it will not have kinetic energy. So we define it through this. Kinetic energy is basically half mv square. That means kinetic energy, it depends on two entities. It depends on mass of the object. Larger the mass of the object, larger is the kinetic energy. Larger the velocity of that object, larger the kinetic energy. Clear? So half into mass into square root of velocity is kinetic energy. So kinetic energy, it depends on mass and it depends on the velocity of that particular object. Clear? Right. This is about kinetic energy. Let's move on and talk about potential energy. As I told you, kinetic energy is because, or kinetic energy of an object is by virtue of its motion, whereas potential energy of any object is because of its relative position, or it is because of some sort of electrical charges in it, or some other kind of internal stress in it. The most basic idea of potential energy can be understood for a raising object. For an object which has been raised at a height, it will have some potential energy. For example, if I raise this pen from one level to this level, the potential energy of this pen has increased. And if I just leave this pen, then that potential energy is transformed into kinetic energy and it is going to hit something. It is going to bring some sort of displacement, right? So potential energy by virtue of relative position, electric charge, or some sort of relative stress. Many examples can be found. If an object is raised, or if a spring is stretched because of the position, if a rubber band is stretched, if there is a battery, there are electrical charges, and if there is dynamite, what am I doing is I am putting so much of this igniting material, so much of chemicals at one particular spot. As soon as I ignite it, it is going to blast. Because of that potential energy, it is going to give immense amount of heat and light. So potential energy can be of various types, and there are different formulae for that. We are not going to get into derivation of that as we saw for kinetic energy. But gravitational potential energy is very simple to understand. Gravitational potential energy, it depends on mass of the object. It depends on the height from which it is falling down, the potential energy of falling object, and the acceleration due to gravity. Similarly, if a spring is stretched, what is the potential energy of that spring? The potential energy of spring, it is half kx square. K is the spring constant, x is the extension of the spring. Similarly, if there is an electric charge, then the potential energy of the electric charge would be the charge into electric field into the distance between the two plates, distance from which the charge is moving from one spot to another spot. There is no need to mug up these formulae also, but I want you to understand that potential energy, generally we have a misconception that potential energy from our school days, we simply talk about something at height. Yes, of course, because of relative position, raised object has potential energy, its potential energy will increase. Other things being electric charge, internal stresses, etc. as well, right? So these are the basic categorized potential energy and kinetic energy. The next thing is that since we have different forms of energy, do we see that one form of energy is converted into another? Yes, of course. Potential energy can be converted into kinetic energy. Kinetic energy can be converted into potential energy. For example, here, potential energy. This particular person has now pulled that string. Now, the arrow has potential energy. And as soon as I leave it, because of its position, as soon as I leave it, that potential energy is converted into kinetic energy. And how much kinetic energy it is carrying? It is carrying half mv square. The velocity of the arrow into the mass of the arrow divided by 2, square of the velocity. It is going to give you that kinetic energy, right? So one form of energy can be converted to another form. But there is one particular rule. For any object or for any kind of a system, there is always conservation of energy. That means one form of energy can be converted to another form of energy, but energy can neither be created nor be destroyed. Meaning, for any object, for any system, the amount of energy will always remain constant. That means the potential energy plus the kinetic energy, it will always remain constant. One would be transferred into another. That is the law of conservation of energy. For example, this look at this roller coaster. This particular body here, it has potential energy plus kinetic energy. Now it has potential energy here. This potential energy is transferred into kinetic energy. It reaches here. Right now here it has potential energy and kinetic energy, but as soon as it reaches top, again potential energy. That means for any system in classical mechanics, the sum of kinetic energy and potential energy of any system, of any closed system, it always remains constant. Energy can neither be created nor be destroyed. Simply one form of energy is transferred into another form. That's the law of conservation of energy. Clear? So what we understood work, we understood energy. Now we'll understand what is the meaning of power. Now power is simply the rate of doing work. Simply the rate of doing work. Meaning how much work are you doing in unit time? It defines your power. So power measures the speed with which the work is done. Now that is what we established. As I told you, we started our discussion with the concept of work. We discussed different forms of energy and we said the concept of power. And as I told you, work depends on what? Work depends on the idea of force. Now we have already established force from the Newton's laws of motion. Force, that concept is equal to mass into acceleration. Work depends on this concept of displacement. Energy is basically the ability of this work. Energy is the ability to do this work. And power is this work that you do in your unit time. That's the basic idea. All right. Right. So power is rate of doing your work, or rate at which the energy is transferred, because we established the same thing, that work done is equal to rate of change of energy. Now if rate of change of energy, we use it in the equation, then power is also equal to rate of change of energy per unit time. All right. So this is the basic connection. Work is equal to force into distance. Energy is the ability to do work, and power is the measure of how quickly the work is done. And that is why all three entities are connected through different units as well. Please try to understand, as I told you before, force is equal to mass into acceleration, right? So mass into acceleration, we get kg meter per second square, kg for mass, meter per second square for acceleration. This is denoted through a symbol of Newton. But when you multiply this Newton by meter, you get the unit for work. Unit for work is joule, which is Newton meter. Unit for energy is also same. Please try to understand. Joule is the unit of work as well as energy, because work and energy, I said that they are analogous, right? Apart from that, watt is the unit of power. Watt is joules per second, because I want to see how much work is done per unit time. The unit of time is second, right? There is one more unit that we use in our day-to-day life. Have you received your electricity bill this month? If you have received, just look at the unit. There would be some units mentioned, right? You have consumed 200 units, 300 units, 100 units, right? What are those units? Those units are again expressed as kilowatt hour. Now why do we do it? Because the unit joule, right, the unit joule of energy of or work done, it is very small. And in general, when we consume energy or when we consume power, we do it at a very extensive rate, meaning 1 kilowatt hour of energy is equal to 3.6 into 10 to the power of 6 joules. So if I keep on calculating in joules the idea of power, the unit becomes very, very large. It becomes extraordinarily large. That's why we have created one more unit called as kilowatt hour. How much amount of work is done in an hour, or how much amount of power consumed in an hour. So this is generally that you get in your households. 1 kilowatt hour is the unit that we measure, that we express, and based on that you get your electricity bills, right? Just something that you need to know from exam perspective. Clear? As I told you, again, not a very complicated kind of discussion, because these build basics of your physics, and physics becomes more complicated as we move ahead in 10th and in 11th, 12th. More and more complicated physics based on different theorems, numericals, and proofs. We are not going to focus on those. So work, energy, and power. Clear? Right. That's the end of today's discussion. We'll meet again with the next chapter in our subsequent class. Thank you for watching this. And again, do not forget, follow me on this particular ID at Rahul Sai 222. If you have any doubts, any clarification, if you have any feedback, complaint, suggestion, anything, you can always message me on IG. I do respond on Saturdays and Sundays. Thank you for watching this again. Jai Hind.